at this point, we're ready to talk about our second shape from lesson 8-2, and that shape is a cone. So we're going to study the volume of cones today. Today's date is 5/6. So what do you think about in your world that is cone-shaped?
Ice cream cone.
Ice cream cone, that's okay. Party hat, exactly. Traffic cones.
Regular cones.
Huh?
Regular cones. Just like, the cones that we have the cone that we have on the cross.
So it's kind of like a traffic cone, but it's a smaller one. Yeah. So it's funny, every class, with the exception of last period, mentioned ice cream first. What last period shouted out, which of course it was three boys being loud, was shouted. They shouted out, "Oh, it's what the Cars slept in the movie Cars." Those teepees. Yeah. So I thought that was funny. That's what they thought of, which I like that movie. I thought that was cute. Now, I do have to say there's two types of ice cream cones, right? And actually, you guys are getting recorded right now. Yeah, so shh. So the one kind of cone, this is my dad's favorite. And that's what they call a cake cone. And I don't know why people like it, because it tastes like styrofoam. Okay? Not my favorite. But sugar cones, those are good. And waffle cones are the best of the sugar cones and best of the regular cone shape. So when you talk about ice cream, you can't be talking about the cake cones because they are not actually shaped like cones. They're actually two cylinders put together. So that's kind of interesting. Okay, so let's talk about our two shapes. What we'd studied, the cylinder. And let's talk about its counterpart. Let's see, how do I want to do it? Let's do it this way. The cone. So what's something or some things that are the same and something or some things that are different? So raise your hand and give me something that's either same or different between these two shapes. So we're going to have a little verses. So Shannon, what's something?
The cylinder has a round bottom and the cone has a round top.
Okay. Now, does the cylinder have a round top or just a round bottom? Okay. So if you notice, the cylinder has two round parts, right? It has two circles, top and bottom, but the cone only has one circle. And by the way, the cone can be with the circle on top or the circle on the bottom. Okay, so that's one thing. We have two circles versus one circle. Who knew? Okay, and it's kind of hard to use the word sides, and here's the reason. That's actually, to do three-dimensional, when we're looking at a three-dimensional object from the face, it's going to look like it has straight edges, but it physically doesn't. Okay? But you're right, those two sides are not going to run into each other because they are parallel. So I like that math term. What are you going to say?
I was going to say like...
Okay, somebody else. Something that's the same or something that's different.
What shape?
Either one.
Candle.
Okay, no, I don't want to know what shape it is. I want to know between these two general shapes, what's the same, what's different.
7th grade honor roll and distinguished honor roll students, it is now your time to proceed to the mall area via the side kitchen door. 7th grade honor roll and distinguished honor roll students. Thank you.
Kellen. They are both three-dimensional shapes. So basically, they're the same that they have three-dimensional shapes. They're the same that they have circular parts to them. They're different because we have one that has sides that will never intersect, and you have the cone has sides that do intersect in a point. And they're also different because, two circles versus one circle. Okay, so you guys did a pretty good job. So we know what the formula for the volume of a cylinder is. It's pi r squared h. And because our cone has many of the same qualities, it still has, because it has a circle and its area of the base is pi r squared, and it actually does have the height. So let me draw that in just to remind you. The height on the cylinder goes from center of the bases, the circles, and that's your height. It's at a right angle to the radius. Okay? In your cone, you have your radius, and your height goes from the center of the circle to the point. Now, here's what's funny. I'm looking around, and you guys aren't writing this down. This is part of your notes. If I'm drawing it, you're drawing it. So our cone still has a lot of the same qualities as the cylinder, so its formula for the volume is going to be very similar. What makes it different is that if I superimpose a cylinder onto my cone, you're going to see a lot of wasted space. So I know that a cone has much less volume than a cylinder. In fact, it has a fraction of the volume. That fraction is 1/3. So the two formulas are nearly identical, but the cone has 1/3 the volume of a cylinder. Okay, so that's important. So let's go ahead and we're going to write down a definition for a cone, and then we're going to work on our problems here. So, cone. And you guys hit all the important things. It is a three-dimensional shape with one circular base, as opposed to the two the cylinder has, where, let's see, I want to write this. Let's see. That is connected, and this is the one thing that Aaron talked about, the sides being parallel. Okay, and in a sense he's true, but what are the sides of a cylinder actually? What do we say, describe the sides as? What goes around the center? Are they straight? Are they rectangles? We said they were curved. Well, that's the same thing with a cone. It's curved too. So the circular base is connected by a curved surface to a single point, and that point is called a vertex. Okay? So, three-dimensional, only one circular base. It does have that curved side, but it only comes to a point as opposed to the cylinder that comes to another circular base. So, again, our formula is just the volume is 1/3 the pi r squared h. So we're going to do three types of examples on our homework. The directions are going to be the same for all of them. It's going to be find the volume, round to the nearest tenth. And again, when we round is after we've done the math.
Attention 8th graders, it is now time to proceed. If you are receiving honor roll or distinguished honor roll, you may proceed to the mall area side doors. Congratulations.
All right, so those of you who are leaving, notes will be up on School Loop, and homework is up, will be up there as well. So for the rest of you, let's continue on. So in this particular shape, let's go, guys. We have a job to do. We have two numbers, 3 inches and 6 inches. Let's go, guys. 3 inches and 6 inches. And we need to identify what those two numbers mean. So what does the 3 inches mean? That's your radius. What's the 6 inches? That's your height. So that's all we need to figure out the volume. So we write the formula first. V equals 1/3 pi r squared h. And then we start substituting in numbers. So the radius is 3, and we're going to square that, and the height is 6. So if we have a number that the denominator 3 can go into, that's what you're going to want to take care of. So 3 goes into itself once and into 6 twice. So that gives us pi, 3 squared is 9, times 2. I'm going to bring it up here. And that gives me 9 times 2 is 18, so I have 18 pi. So this is when I use my calculator. And I do 18 times 3.14159. Remember, on the test you won't be able to use the pi button because your calculators won't have them because they'll just be basic calculators. And you get 56.54862. Now again, all I really care about are the first 2 numbers after the decimal point. Is 4 large enough to round 5 up, or does 5 stay? Okay, it's just shy of being what we need. So basically our answer is about, or we could use the squiggly equals, 56.5, and what would the label be for this one? Cubic inches. Okay? The next problem we're going to do is a word problem. Yes, Peyton. Yep. No. It's whatever you could. I could have canceled 3 with one of the 3's from the radius, because remember 3 squared means 3 times 3. So I only get to cancel that denominator with one number. And I was lucky I had 2 to choose from. That doesn't always happen. Okay, in fact, the next 2 examples, there's nothing for it to cancel in, so I'll show you what that looks like. Okay, so next one we have a little bit more to write because it's a word problem. So this one says, a cone-shaped paper cup is filled with water. So I see these like at a doctor's office or a dentist's office. Yeah, the bottom of snow cones too. But that they have these little cone-shaped cups for water. Okay, and you just take your water, throw it out. Filled with water. The height of the cup now the good news is you don't have to do this when you're doing your homework, but we do it in our notes, is 10 centimeters, and the diameter is 8 centimeters. What is the volume of the paper cup? And then again, we know that the directions are embedding round to the nearest tenth. Okay, so you have a couple ways to proceed with this. Most of the time in a geometry class, your teacher's going to ask that you actually draw a picture of it because it helps you visualize. And then you can label it with the information. So I'm going to do that. And since it's a cup, the circle would be at the top. And it tells me that the diameter is 8 centimeters and that the height is 10 centimeters. So I start by writing down the formula. Volume is 1/3 pi r squared h. And then I start substituting in what I know. So they gave me a diameter, so the first thing I'm going to have to do with the diameter is I'm going to have to turn it into a radius. So if I cut the diameter in half, that gives me the radius is 4 centimeters. So we're going to square 4, and then we're going to multiply it by the height of 10. Now notice in this problem, we do not have anything that 3 can go into. So what's going to end up happening when we're doing our calculations, we're going to calculate everything in the numerator, get an answer, and then the last thing we're going to do is divide by 3. So we're going to get pi, 4 squared is 16, times 10, no, divide by 3, and you should be able to say, oh, that's just pi times 160 divided by 3. So the answer works out to be 167.5514 and the sixes just repeat. So again, we're going to round to the nearest tenth. And is 5 large enough to make 5 pop up to 6? It is. So our answer is the volume of the cup is about, that tells you it's rounded, 167.6, and the label would be what? Cubic centimeters. Okay? So notice I had a word problem, so I got a word answer. Okay? So the last example I want to do for you is one of those composite figure ones. Is everybody good here? Okay, so this is the last one, then you guys will have time to work on homework. So we've got a shape here. So they tell us that the dimension across is 8 feet. From the top of the top shape to the bottom of the top shape, they say it's 4 feet. From the top of the bottom shape to its very bottom, they say that's 5 feet. So again, what we're going to do is identify each of the pieces. We're going to figure out the volume of each of the pieces, and then we're going to add those volumes together. So what's the first shape on top?
Cylinder.
Okay, so we're going to have to figure out the volume of a cylinder. And what's the bottom shape?
Cone.
A cone. So we're going to have to figure out the volume of the cone. So the formula for the cylinder is pi r squared h, and for the cylinder it's pi r squared h, and for the cone it's 1/3 pi r squared h. So let's identify, do we have a radius? No. This 8 feet was the diameter, right? So if we just cut that answer in half, it gives us a radius of 4. Now, what's interesting is both of them have exactly the same radius because both of them have the same circle in common. And the two circles of the cylinder are congruent, so that means their radii would match. So the cylinder's volume is pi, and then we have 4 squared. And then what's the height of the cylinder?
4.
That's another 4. Now when it comes to the cone, we have 1/3 pi. The radius is still 4, and we're still going to square it, but what's its height?
5.
Okay. So then we just start doing math. So let's see, we get pi, 4 squared is 16. I can do 16 times 4, and I get 64 pi. And then I use my calculator, and I get 64 times 3.14159. And we get 201.06176. I'm going to round this one to the nearest tenth. Is the 6 large enough to move it? Yeah, it is. So for this one, I get 201.1, and the label is cubic feet. Okay? We're not done with it. We just did the cylinder half. Now we're on the cone half. So now we get the third again. Now, notice that 3 can't go into 4 or into 5. So we're going to rewrite the problem so the 3's in the denominator. Now I can do what 4 squared is. It's 16. And I should be able to multiply 16 by 5 pretty readily. And that gives me 80 pi over 3. And then that's what I'm going to end up doing, is multiplying 80 times 3.14159. Hit equals. Divide by 3. And I get 83.7757, and then we get the repeating 3's. So again, we're going to round to the nearest tenth. Is the 7 enough to shift up the 7? And the answer is yes. So this becomes 83.8 cubic feet. So all we do is add these two together, lining up decimal points, and we get the final answer. The volume of this composite shape is about 284.9 cubic feet. Okay, and that's it for dealing with the composite figures. All right, so you have time to be working on homework now.